Okay, yes, moving on. Before we begin to take questions now, so I'll just explain some things again, then we'll start taking questions. Let me write the formula again. The first formula, we have what? N over N naught is equals to 1 over 2, right? Into bracket, capital letter T over what? Over T half. So this is your formula, right? And I said your N naught is the what? Is the initial amount. Your N is the what? Is the final. Yes, what if there are some questions they can just ask you to find the fraction? Yes, so if you have N over N naught, that's the fraction that decayed. The fraction that decayed. Please never forget this. Yes, we already talked about our T. That's your what? Your time. Your T half is in what? Is your half-life. Is your half-life. Yes, there are some questions that can ask that what's the fraction we have left? What's the fraction left? Yes, what's the fraction that is left maybe undecayed? Yes, what's the fraction you have left? The fraction will be what? 1 minus N over N naught. This is the fraction that decayed. So the fraction that will be left will be 1 minus this fraction that decayed. That's N over N naught. Yeah, please take note of that. So with this, you should be able to solve all calculations related to this topic. Let's go over it again. N over N naught is equals to 1 over 2 raised to power T over T half. Then N naught is what? Your initial amount. N is the final. N over N naught is the fraction that decayed. Then T is your time. T half is your half-life. So the fraction that will be left on decay is what? 1 minus N over N naught. So let's take care of that. Let's begin to take questions now. Okay, so we have the first question here. In 24 days, the radioactive isotope decrease in mass from 64 gram to 2 gram. What is the half-life? Yes, what's that? Your 24 days is your what? Is your time. Write it. Time is what? 24 days. Decrease in mass from 64 gram from, this is your what? Initial amount, from your initial amount, 64 gram. I don't know if you get what I'm doing. To what? To 2 gram. This is your final amount. That's 2 gram. Then they said, what's the half-life? What's the half-life? So you are good to go. Let me explain again in case you don't get the interpretation of the question. In 24 days, your 24 days is the what? Is your time. Then they said, what's a decrease in mass from 64 gram? So it is initially 64 gram. So N naught is 64 gram to 2 gram. So your final amount is what? 2 gram. So they said, what's your half-life? Write the formula. N over N naught is equals to 1 over 2 raised to power T over T half. Right? Yes. What's N? N is what? 2. What's N naught? N naught is what? 64. 1 over 2. What's capital letter T? That's what? 24. Over, what's T half? That's what you are looking for. So just solve accordingly. 2 here 1, 2 in 64 is what? 32. So you have something like this. 1 over 32 is equals to 1 over 2 raised to power 24 T over 12. T half, I mean. Yes, now this is just what you need to do. 1 over 2 here, you have 1 over 32 here. That's just the law of indices. Check out something. 1 over 32 is the same thing as what? 1 over 2 raised to power 5. Do you believe? Yes, 32 is what? 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2. I just think this 6. Yes, so that's what? 2 raised to power 5. So I can write it here. This 1 raised to power 5 is also the same thing as 1. So I can write it this way. 1 over 2 raised to power 5. So this one is the same thing as what? 1 over 32. So let me just replace my 1 over 32 with what? 1 over 2 raised to power 5. So you have 1 over 2 here, you have 1 over 2 here. You can easily what? You can equate the power. So you have 5 is equals to, what's the meaning of equating the power? Just equal the power to each other. 5 is equals to what? 24 over T half. So you can cross multiply. 5T half is equals to what? 24. Yes, permit me to use this small space. So we have what? T half is equals to 24 over what? Over 5. TF is equals to 4.8. What will be your units? They said days. 4.8 days. There are some questions they will intentionally put hours, especially if the marker is very wicked or if they want you to fail. So you must be wary of your what? Of your units. So that's how we got that. Let's try another question now. Yes, you can pause this and try this question again on your own. Then you try writing it and solving it. In 24 days, a radioactive isotope decreased in mass from 64 gram to 2 gram. What is the half-life of the material? Okay, yes, let's go now. They said the next question, a radioactive isotope has an half-life of 8 days. What fraction of the atom will remain after 72 days? What fraction will remain after 72 days? So this is how to tackle this type of question. Yes, what's this? Half-life of 8 days. Half-life of 8 days. After 72 days, that's your what? That's your total time. That's your period. Yeah, 72 days. Now let me just make an important sketch on radioactivity generally. Let's say you have a block. There's a block, and the half-life, the number of atoms present, you will notice what? 100 atoms or 100 gram. Yes, let's say the half-life is 2 years, right? So after the first 2 years, this atom will do what? Will reduce to its half. So it will become what? 50 gram. This is after the first 2 years. This, let's say 4 years. Yes, after another 2 years, 6 years, to reduce to its half, 25 gram. After another 2 years, 8 years, to reduce to its half, 12.5 gram. That's what half-life actually is. So if you ask to find the amount remaining, what you are finding is this is your what? This is your final, this is your what? Initial. N over what? N naught. So this is the amount remaining, this is the fraction remaining. The fraction you have left, this final minus initial. But there are some questions they will ask you, what the fraction that has decayed? The fraction that has decayed is all this one. That means they want to find, you have, this is the final now. Yeah, 12. So they want to find 12.5 gram. They want to find the amount that has decayed. So it's just, I gave you the other time, I said it's 1 minus what? N over N naught. Don't worry, we'll take a question on that, then you'll understand better. But yes, let's move on with this question now. Okay, yes, so these are the next types of question. So I'm sorry. Okay, yes, so these are the next types of question. So we'll be taking them one after the other. So do well, just get a pen and try to solve as we move on. The half-life of a material is 6 hours. Okay, half-life is what? 6 hours. What quantity of 1 kilogram of the material would decay in 24 hours? That 24 hours is what? Is your, is your time. 24 hours. So they said 1 kilogram. That's the what? Initial amount left. N naught is what? 1 kilogram. Do you understand now? So they said will decay in 24 hours. So we've written that. So they're now asking you that what quantity out of all this 1 kilogram, what quantity of it will decay? So the first thing to do is that first of all get the quantity that will do what? That will remain. So yes, let's get the quantity that will remain first. So that's your what? Your N. N is the final, the one that will remain. So let's go. N over N naught is equals to 1 over 2 capital letter T over TF, right? What's N? N is that's what you are looking for. What's your N naught? N naught is 1 kilogram is equals to 1 over 2. What's this? 24 over 6. 6 in 24, that's what? 4. N over 1 is 1 N. Then you have 1 over 2 raised to power 4. That's what? 1 over 16. This is your what? The one remaining. But they ask you to find what has decayed. So if this is what is remaining, what's the quantity that is what? That has decayed. I gave you the formula. 1 minus N over what? N naught. So 1 minus, this is the one remaining, 1 over 16. So that's what? 16. 1 is 16. 16 times 1. 16 minus 16 is 16. 1 times 1. 1. 16 minus 1, that's what? 15 over 16. So this is the fraction that's what? That has decayed. the fraction that has decayed. So please take care of that. Take care of that. Let me give you a question to practice. And would you like to practice a question on this? Yes, so this is the question I want you to try. That first one, the half-life of a material is 3 grams. What quantity of 1 kilogram of the material will remain in 15 grams? Yes, so check it out. Yes, can you try it? Just pause this video, write out your parameters and try to solve. Okay. Now I believe you are done with the solving. Yes, let's solve it together. Let's see if you get it. The half-life is what? 3. I'm sorry, this should be 3 seconds. Just change it, 3 seconds, 15 seconds. That was poorly framed. Yeah, so the half-life is what? 3 seconds. What quantity of 1 kilogram? What do you have initially? 1 kilogram. Will remain in 15 seconds. Time. In this place, what are you asked? Remain. In that other place, what are you asked? Decay. So this one is what? More straightforward. You are just looking for your what? N. Yeah. What quantity would what? Would remain. So this is what you're looking for. So just solve it. N over N naught is equals to 1 over 2 T over T half. Right? N over, what's your N naught? 1 over 2. What's capital letter T? 15 over 3. N is equals to 1 over 2 raised to power what? Raised to power 5. N is equals to 1 over 2 raised to power 5. 2 times 2 in 5 places, that's what? 32. If you get it, give yourself a clap. Just give your kudos to you. Let's move on now. Next question now. Yes, just write out your parameters for this if you can try it out. The half-life is 24 hours. Calculate the fraction of the original element that would have disintegrated in 96 hours. Okay, are you trying it out already? Yes, write out your parameters. Just pause the video, then you play it again. Okay, I'm sure you must have done that now. Half-life is what? 24 hours. Yes, the fraction that would have what? Disintegrated. So this one is not remaining. What would have disintegrated in 96 hours? This is your time. 96 hours. So you are looking for your what? What has disintegrated? That's technically what? 1 minus N over N naught. Yeah. Yes. So you know how to get it. N over N naught is equals to your formula 1 over T over T half. Then what's your N? Your capital letter N is what? That's we aren't given. N over N naught. 1 over 2. What's capital letter T? 96 over, what's T half? 24. So you divide, to give you what? 4. N over N naught is equals to 1 raised to power 4 is what? 1 times 1 in 4 places. 1. 2 raised to power 4, 2 times 2 times 2 times 2, that's what? 16. So if you put this down as your answer, you will be wrong because this is the fraction that is what? Remaining. But they're asking for the fraction that has what? Disintegrated. So that will be what? 1 minus N over N naught. So that's what? 1 minus 1 over 16. So that's what? 16. 1 is 16. 16 minus 1. 15 over 16. I hope you get it now. So that's just about that. So yes, I modified another question for you. Yes. Can you try it out? Yes, just pause the video. The half-life of a radioactive element is 24 hours. Calculate the fraction of the original element that would remain in 120 hours. So just pause it, solve it, and yes, let's quickly take it together now. I'm sure you are done now. Yeah, so your half-life is what? 24 hours. Your time is what? 120 hours. They said the fraction that would what? Remain, N over N naught. That's what you are looking for. This your what? N over N naught, the fraction. So it's equals to 1 over 2 T over T half. N over N naught is equals to 1 over 2. That's what? 120 over 24. N over N naught is equals to 1 over 2 raised to power what? Raised to power 5. N over N naught is equals to 1 over 2 raised to power 5 is what? Is 32. So this is the fraction that will do what? Remain. That's what you are looking for. You are not asked what fraction would have disintegrated. This one, what fraction would remain? It's as simple as that. So I believe you should be able to solve all this next question on your own now. Okay, pause it and try it. They are all jam questions. Try it out. Yes, I believe you must be done now. They said half-life of what? 20 hours. Right? What fraction will remain? You know the formula to that already. And your time is what? 80 hours. So they said what fraction? So you aren't bothered. N over N naught is equals to 1 over 2 capital letter T over T half. N over N naught is equals to 1 over 2 80 over what? Over 20. 2 in 8, that's 4. N over N naught is equals to 1 over 2 raised to power what? 4. N over N naught is equals to 2 raised to power 4 is what? 16. So this is what? 1 over 16. Do you get it now? So they said what fraction will remain? So this is your answer. If they said what fraction will disintegrate? That's what? 1 minus 1 over 16. Yeah. Try the next one too. A radioactive substance has an half-life of 3 minutes. After 3 minutes, the count rate was after 9 minutes, the count rate was observed to be 200. What was the count at 0 time? This is very simple. The half-life is what? 3 minutes. After 9 minutes, that's your what? Your time. The count rate, yes, was observed to be what? 200. So this is after some time. So this is your what? N. 200. They said what's the count at 0 time? Initially, N naught. So I believe you can finish it from here. So pause it and finish it from here. So I'm sure you have done that now. Let's move on. N naught. Let's cross check if you got it. N over N naught is equals to 1 over 2 T over T half. Yes, N is what? 200 over N naught is equals to 1 over 2. What's T? 9 over what? Over 3. 3 in 9. That's what? 3. So you have 200 over N naught is equals to 1 over 2 raised to power 3. 200 over N naught. What's 2 raised to power 3? That's what? 1 over 8. 1 over 8. So you just cross multiply. N naught times 1. That's N naught. 200 times 8. That's what? 1600. Yes, let me give you a question like this now that you can try out. So I've modified the question now. Try it out. Kindly pause it and try it out. Has an half-life of 4 minutes. After 16 minutes, the count rate was observed to be 100. What is the count at 0 time? Yeah. So the half-life is what? 4 minutes. After 16 minutes, was observed to be what? 100. N is what? 100. What's the count at 0 time? So this is very simple. Yes, you can pause and try it out on your own. I'm sure you are done now. So you have 100 over N naught is equals to 1 over 2, 16 over 4. 4 in 16, that's what? 4. 100 over N naught is equals to 1 over 2 raised to power 4 is what? 16. N naught is equals to 16 times 100. You got what? 1600. So that's your what? N naught. Please take care of it. Yes, but before this last question, let me give you, okay, to not even be the last question, I can just give you some little more questions to practice with. Yeah, before this question, let me remind you of some things. Let's say we have what? Yes, in the formula we have N over N naught is equals to 1 over T. Raised to power what? Yes, I gave you a formula in the beginning. I said there is an N here. And I said this N is what is equals to what? T over T half. I said this N is actually what? The number of half-lives. So there are some questions that they will say, how many half-lives are there in this reaction? So that's the question for this last one. If it takes a certain radioactive material 250 days, that's a what? Period. 250 days. To reduce to 1 over 32 of its original number. So N over N naught is equals to 1 over 32. Yes? They said the number of half-lives is, the question isn't very complete. Yes, the number of half-lives is, so you are looking for your N. So you have N over N naught is equals to 1 over 2 raised to power N. You actually don't need this one. Yes. What's your N over N naught? 1 over 32 is equals to 1 over 2 raised to power N. Right? So just simplify this one. 1 over 2 raised to power what? Is the same thing as 1 over 2 raised to power 5. 1 over 2 raised to power n. So just equate it. N is equals to 5. So this is your number of half-lives. You have 5 half-lives. So there's a difference when they ask you that what is the half-life and what's the number of half-lives. If they say what is the half-life, what are you looking for? You are looking for T-half. If they say what's the number of half-life, you are looking for what? N. So take note of that. Yes, that's all about the basic calculations in radioactivity. Let me just put down 3 questions that we can try. Then after that, you watch out for the next video on nuclear fusion, binding energy, and some other complex questions in radioactivity. And that will be all for radioactivity.